This is part 1 of online lecture 1. In this part, I will discuss why do we study the interference phenomenon of light. We can use the interference phenomenon of light to determine the wavelength of monochromatic light. Suppose you are working with a light whose wavelength unknown to you, but you need to know the wavelength of light. Then you can use the interference phenomenon of light for the determination of the wavelength of unknown light. The interference phenomenon of light can be used to measure the thickness of a thin film. What is a thin film? The thin film means the thickness of the film compared to the wavelength of light. That is, the thin film thickness in the nanometer range. So you cannot measure this tiny thickness with the help of a standard thickness measuring instrument such as meter scale, slide calipers, screw gauge, and spherometer. But you can easily measure this tiny thickness using the interference phenomenon of light. Figure 1 and Figure 2 show a thin film of soap and oil. These films showing different colors. Why does this film show different colors? For example, 1 liter of oil in a pot does not show any color, but if you put a drop of oil on water, show an array of color. A substance that is normally colorless and clear can give an array of color when it is found in a very thin layer. As shown in the figure 3, the light wave incident on a thin film produce two reflected waves by the method of amplitude divisions. They act as a coherent source as they produce from the same incident wave. And they will produce interference patterns by the superposition of these two reflected waves. When white light incident on a thin film, such as a layer of soap, a layer of a thin layer of soap or a thin layer of oil, the interference pattern of different color are produced due to the superposition of reflected waves created from the same incident wave by the method of amplitude divisions. That's why the thin film show an array of colors. We can also use the interference phenomenon of light to determine the radius of curvature of a plano-convex lens.